Enlightenment. Oh my gosh.
Hello, everyone, and welcome to this week's Stella Developer Meeting. Today we have two things on the program. We have first G. She will present the latest updates to Stella Lab, which I'm super excited about. It's a tool I use almost every day. And then later, Jane, also from the DevX team, will join and talk about upgradable contract proposal. So let's get started. I think it was in December, early December. We had the last presentation of Stellar Labs, but a lot has happened since then. So I'm super excited about learning more about the new features. And yeah, take it away, G.
Yeah, awesome. Thank you, Karsten. Oh my God, I'm so excited to see like Emir Enlightenment in this chat. Hello, my name is Jason. I'm on DevX team. We work on CLI, lab, quick start, and more things. But I'm primarily working on the lab, and I'm very excited to show you guys what we have built so far for smart contracts on Stellar. So I will share my screen, and I'm going to share my entire screen because I want to do some CLI work as well. So can everybody see me? Okay, great. I think, Karsten, did you share my Notion doc?
I am going to do that right
Yes,
now.
please. So I'm going to walk you guys through what we're going to talk about today. First of all, we're going to go through overview of smart contract features on Stellar. So Contract Explorer, we're going to take a look at Blend Pool Contract and Kale Contract by Tyler, and sort of like kind of go through like each feature that we built. And the second of the presentation will be live demo, which I might break something. I actually did break something back in December, so who knows? It might happen again. I hope not. I practiced, but yeah, I feel like in the world of AI, actually breaking things is now like in. I think. So okay, let's go to the lab, our public lab. I should have removed this bar, but okay, whatever. So to use smart contract features, we have to make sure that our RPC URL is ready, and I do have that, which is provided by Overcat mainnet.sorbanrpc.com. So thank you, Overcat, for working on that. So this is the new feature that we built. Our team member Iveta built this. So big shout out to Iveta. So I'm gonna copy this contract and bring it here. And this is going to give me all the information about Blend Pool contract. And this is, we're getting API for this from Stellar the Expert. As you can see, I have like powered by Stellar Expert here. So here we have, it shows source code of Blend, which is how we verify that this build is verified. So on Stellar, unlike others, some smart contract platforms, we don't store source code on Stellar. So what we do here is we are checking GitHub action and making sure that the commit that this GitHub action ran matches the source code. And that's how we verify the contract here. And we have about 10,000 entries here. So it might take some time to load this, but this will show you all the storage that are available on this contract. It takes some time. But yeah, it like shows up here. And this will be really useful when you have to extend TTL or restore footprint for contract storage. I will walk you through this later in the demo. But yeah, we have a way to export this in CSV. So we go here, it will show you all the XDR that we have. And like I said, I'll walk you through what we can do with this later. I'm just gonna close this for now. And source code is coming up. Contract spec is kind of like, this is like our way of, our version of Ethereum's ABI. It shows you the data types that this contract has and then functions that this contract has. And later demo, I'm going to show you what we can do with this contract spec to build some of the functionalities on the UI side. And binding is coming up as well. So let's look at Kale. So Kale's going to be a little different. I don't think it has bill verified yet, but it will show us how big their entry or their contract storage is. It's like almost like 3 million, I think. So it might take some time to load, but I just wanted to show you guys. It shows us all the version history. And I'm not gonna, okay, I'll click contract storage. It has 3 million entries, which is wild. But yeah, it shows all the information that the users want to know about the contract on the lab, which is great. Yeah, failed to fetch. We'll show that later. It worked earlier. It might be too big. Yeah, so like here has all the functions and data types. We can also do XDR if you want. You can copy. You can also download the WASM. So let's say you're building a contract that also want to interact with other contracts. You can download the WASM and deploy it within your contract. And we also have smart contract list, which shows us all the smart contracts that are built. So at the moment, everything is being rendered by front end. So what we're going to do to make this load much faster, we are going to work on implementing backend so that it will be more efficient and faster. But yeah, give it some time. Or I can also refresh. Should I refresh? Let me refresh. Okay, yes. So yeah, all the smart contracts that are happening. I can just click on it and then we can just load it right away and check out what's going on. So yeah, so that was the overview of smart contract features on Stellar. So what I'm gonna do next is kind of go through the live demo or like live coding or like building the contract and see how a developer can really utilize the lab to make their workflow much better. So I'm going to build a contract on testnet. OpenZeppelin recently launched SEP 41 token standards here. So look at all this beautiful token. And I'm going to use James's tutorial to build like sample contract really fast. So James is actually using OpenZeppelin's Mintable standard to get the contract working. So I already did, let me duplicate it. So I already built, cloned his repo and did the first 5 steps. So all I have to do is start contract deploy. So let's go to let me just go like this. So Stellar keys, JSON, Stellar keys, Stellar keys, let me do the ls. Here's address, JSON, I need to do my address. Okay, so I'm gonna do is the source who is responsible for all the transaction and anything related to this contract is going to be me, JSON. And just to make this work easy, I'm going to make the owner of this token contract my address, and I'm gonna limit my token at 10,000. And let's deploy this. I hope you work. Yes, it better work. Sign in transaction. Okay, cool. So that one is deployed. So this is our contract. And I think what I want to show you is our upcoming feature, which is invoke contract. So the way we invoke contract on the CLI is like this, which I kind of find it a little difficult, or it's not very intuitive. I love our CLI, so don't get me wrong. And it would be sources JSON. And let me actually show you another feature of the lab, which is a creating key pairs, which is super useful because I'm going to account, generate account, and I'm going to fund this account with FriendBot. when you like develop on any contracts, it can be really confusing with like all these public keys. So I'm gonna save this key pair, and it's gonna be testnet open Zeppelin invoke account, and going to save key pairs, and I'm gonna copy this, go to my CLI, and I'm going to mint 1,000 tokens to this account. Amazing. Yep, successful. Great. So if I go to this contract on Stellar.expert, we'll see 2 data entries. Yep, GB, I just did that. What I'm gonna show you next is our upcoming feature, which is doing invoke contract on the lab. So I've been working on this. It's been taking quite some time, but I am going to walk you through. First of all, I need my keys address JSON, which is this. I need this. I'm on testnet. Patch this. I think I will need my private to sign later. No, was it Stellar keys show? Okay, I need this later to sign. So what I'm gonna do is I'm going to invoke, not payment, invoke contract, and our contract was this one. Go to this, and I am able to fetch all these methods from contract spec that I showed you earlier. So I'm gonna do mint. And let me reuse the account that I did here. I'm gonna mint some more on that account. I'm gonna do prepare transaction, which gives me this XDR. And if you go to XDR view, it's gonna tell me that contract address is this. I'm calling function mint, and this is the destination address. And all the information is about what this TX is about to do. So good, I like this, it looks great. It also tells you the resource fee. All right, I'm just gonna go ahead, I'm gonna sign it, and I'm gonna sign it with this. Don't ever do this, don't ever show your secret key. I'm just doing this because it's a demo and it's testnet. So I'm going to sign, my transaction is signed, and I'm going to submit in transaction submitter. And same thing that we saw earlier, looks good. Let's hope this works. And yes, it worked. Okay, so we have all these envelope, XDR, fee. I can go to view on Stellar Expert, and it showed me that this transaction did indeed work. And if I go to this contract, it shows that mint did happen. And this all happened from the Stellar Lab. And so yes, that worked. One last thing I want to show you is our popular stay archival. So we have a way to restore and extend TTL for contract storage, and I'm gonna show you how to do that. So let's go back to our contract, which was this. And what you can do is that you can go to lab, smart contract, this feature is live. I'm going to load this contract, and in this contract storage, we have this balance. And let's say this balance is like expired. In that case, I can download this, go to my CSV file, and it will show me that there is a key. Instance is like entire contract instance, and this is the contract storage key that I want to extend or restore. Then I just copy this, and let's check view XDR and see what that contract storage key is about. If it's smart contract value, and it tells me that this is the balance and address this. And let's say I want to extend footprint for that one. And I think I have to go to my account and I'm gonna get this. And we can do extend, this is live, and contract, get this, and get the SC val, right here. I'm just going to testing, just 200 sequence ledger and resource fee. And I have this button called fetch minimum resource fee from RPC. This does all the simulating and everything for you. And you go sign in transaction. And I think secret key is this one. And we can submit the transaction. And yep, we were able to extend our TTL for that contract storage. So yeah, GBTLT, extended legit state expression to sequence 200. So that's the demo that I have. You probably won't ever use extend TTL because I think the app should take care of that. And kind of same thing with restore footprint once protocol 23 comes, but the lab can support it. So if you ever need it, just come to the lab. And that's the demo for today. Thank you.
Great, thank you. It was super interesting to see all these new additions. And now I would like to invite Jane to the stage here, who will give an update on one of the SCPs.
Alrighty, thanks for having me. So today I'd like to talk about the Upgradeable SEP, which is a SEP that defines how smart contracts can upgrade themselves, and is contributed by OpenZeppelin. They've been doing a lot of great work for us, shipping fungible token, and also now NFT and upgradability. And this is really a call for the community to look at the SEP and also look at the smart contract code that they're shipping for us and add your comments. So as you know, the contracts on Stellar are mutable by default. And the mutability in the Stellar ecosystem means a contract can modify the WASM bytecode, thereby altering its interface, execution logic, metadata. So there are also cases where you want the contract to be immutable because it guarantees the trustless execution and the application of the contract logic. So if you think about Blend, that is a immutable contract. But typically in a more common case is, DeFi protocols, or if you're building a game, if you think about over time, you might want to add more features, functionalities to what you're building, you probably would want contract upgradability. So in order to do that, we were working with OpenZeppelin, and we published the SEP. And Carsten, could you share the SEP, please?
Yeah, I just shared it.
Thank you. So it creates a standard to define how smart contracts should upgrade their WASM bytecode. And also talks about some of the caveats you should think about while you're upgrading, such as a new contract shouldn't have a constructor because that constructor is never getting invoked. Or if your existing contract is upgradable, you should be careful not to upgrade to a contract that no longer has upgradability. So you're stuck there. So are users. And you should check for storage consistencies, making sure that the new contract does not introduce any storage mismatch. And also, one more thing we actually describe in the SEP is to add a metadata that describes the current SymVer. So essentially a new key value pair called BinVer, and the value follows the SymVer standard major minor patch. And that would describe to the world of your contract and its upgradable path over time. And there is a simple code in the SEP, which you can see if we go down to that section. And it will basically define a public function upgradable and get the owner's address, require auth, and then call the update current contract WASM and put in the new WASM hash. So that is basically the SEP. And then if we go to the OpenZeppelin source code at github.com, OpenZeppelin contract utils here, you can see that there is upgradable macros, and this will make it so that you can easily add these macros to your contract, and eventually it's going to be integrated into the Open7 wizard. And you can decide if you want your contract to be upgradable and use these macros. So this app is basically out there, and we'd love to get your feedback. Please comment and provide us feedback, and hopefully we'll get these audited and merged very soon.
Great, thank you for the introduction, and yeah, everyone, please go to the pull request, and if you have any comments, any questions, any concerns, please write a comment, and yeah, we'll address it. I think that was it for today. I think this was really interesting, both getting an update on Stellar Lab, but also getting a view into one of the SEPs that are coming up, and really encouraging everyone to take a look at it and provide any feedback you have. That's it. That's all we had for today. Thank you everyone for joining. We'll be back again next Thursday. Thank you. Take care. Bye.